Hello, everyone. I'm Amit Purohit. I'm a senior manager of engineering at RDS. I manage the cross-platform services group, which means that any service that go across database engines, my team is responsible for building that service. Similar to any other engineering organization, we launch these services on an engine-by-engine basis, such that we can do a gradual rollout, and we can also ensure that the blast radius is reduced. Over a period of time, we get good customer feedback and are able to roll out to other engines. A little bit about myself. I've been with AWS for almost 5 years. I started with EMR, our analytics service, moved on to help launch Glue, which is our ETL service, and for the last 2 years, I'm with RDS. AWS provides purpose-built databases because we know that customers have different applications and different needs. Today's session is specifically around our relational database offering, and what I'm going to talk about is what we've launched since last reInvent, and then a couple of key launches that we've done at reInvent 2019. RDS is about choice. You can get open source engines like MySQL, MariaDB, and Postgres. You can also get Microsoft SQL Server and RDS Oracle with RDS, and our homegrown cloud-native Amazon Aurora with MySQL and Postgres compatibility. With RDS, you do not have to worry about standard management tasks, provisioning, backups, all of the standard tasks that a database administrator have to do to set up a database, to operate a database, or to scale the database. Those operations are done through RDS as a service. It's secure, it's compliant with different industry standards, and available as well as provides the same durability as you get with the standard engines. I was in the market initially to buy a family car. When I was buying this car, I was looking for 3 distinct feature categories: foundational features, engine type, mileage, security, value-add features, such as comfortable seats, a great entertainment system, and then value-add features, innovative features, such as lane assist, auto steering, or something that is important to my entire family. Now, it turns out that whenever people go through a process of buying a product or a service, they apply a similar kind of feature categories. There could be different names for these things, but the intent is to have a set of categories and be able to pick every product and apply those categories so that you can determine the best product. So what we'll do today is to apply these feature categories to RDS and pivot our session to talk about features in each of these categories. By the end of the session, you'll be able to identify what's available in RDS and what we are presenting or launching at this reInvent. Foundational features. Security is a top priority for RDS and AWS in general. We launched encryption at rest in our China regions earlier this year. What this means is that encryption at rest is available everywhere for RDS, and it's as soon as you enable encryption at rest on a database instance, it's applicable to the underlying storage, read replicas, and backups. So with a click of a button, you can enable that encryption across all of these resources. RDS encryption uses the industry standard AES 256 encryption algorithm to encrypt your data on the server that hosts your RDS instance. With cloud, customers like the flexibility of pay for what they use, rather than locked into a long-term price. With RDS, you already pay for that price. Over the years, customers have told us that they also have database instance that they need for a short-term need. Dev test workload, or a workload for integration testing, performance testing, or any other suitable needs. The challenge is that those instances may not last for the entire 1 hour that a database is charged for. What this means is that customers start to build application logic to maximize that 1 hour for the database instance price. What we launched earlier this year is a per-second billing. Customers can now choose to use their dev test workloads and are charged in the increments of 1 second. So if you have a database and you started it for a dev test workload and you want to run it for, say, 15 minutes, you're only charged for 15 minutes. And once you shut down the database, there is no additional charge for that. And you're charged only in the increments of 1 second. Since these instances are provisioned for shorter duration, it helps customers if they are charged in smaller increments, and that's the intent of doing a per-second billing. If you combine per-second billing with some of our other offerings, like stop-start feature, customers can save a lot of money. The next 3 bullet points, I will talk about them in the slides because they have some detailed screenshots that you will be able to see and take pictures for. Customers give us feedback about storage that we provide with RDS. So in 2017, we launched support for 16 terabytes for storage for all of our non-Aurora engines. With modern applications and with applications that require a lot of data ingested on a daily basis, we added support for 32 terabytes, and then earlier this year, we added support for 64 terabytes. But we didn't stop here. We didn't want customers to provision for peak capacity, which is a basic tenet for a cloud service or a cloud database service. And so what we did was enable storage autoscaling for our non-Aurora engines. Aurora engines already support storage autoscaling, but with this feature, you do not have to pay or provision peak capacity. You just provision what you need at the moment in time, and then you set a threshold, so when you need extra capacity or extra storage capacity, in fact, the service enables this particular capability and increases the underlying storage when you need it, so that you're not paying for the same capacity when you do not intend to use it. So this is about storage. Let's transition to another important category around security. We have a capability where customers can use database credentials, like username and password, to connect to a database. We also have a capability for customers to connect to a database using IAM authentication. Customers over the years have told us, especially our enterprise customers, have told us that they need a single sign-on capability. What this means is that if they have their own domain controllers, like Active Directory, they already have username and passwords for customers, for their users. Rather than creating those users again, they want those same user credentials to be validated by the database and be leveraged by the database, so they can apply the policies, they can apply the permissions in a single place or a single location. So what we did is we've launched a support for Microsoft AD integration. Customers now have a choice to pick one of the 3 options that are on the screen: password authentication, password and IAM database authentication, or the Kerberos authentication. No software installed, no additional charges, easy to set up, and in this case, you can use Amazon-provided Active Directory, or you can use the on-premise Active Directory that you have for your organization.
This is as of January.
Yes. This is available as of July. This is available as of October 2019. It's available in Oracle, RDS Oracle. It's available for RDS Postgres, and it'll be available for rest of the engines soon. Finally, before we transition off from the foundational features, I wanted to give you a view of what console experience looks like. This is our console experience from last year. If you notice here, setting up a database exactly what you want requires a lot of configurations. Select an engine, provide some details, provide some more details. What we realized based on user studies and talking to many of our customers is that while some customers like the advanced functionality, majority of our new customers want to get started quickly without a lot of settings. It's like a coffee machine. I start with a one-click coffee, and then as I migrate to different coffee options or different options with a particular coffee machine, I want to buy an advanced coffee machine which has a lot of different options. So what we launched earlier this year is what's new, an easy create option. One-click button, you get database set up, standard configurations already picked by our team. You can obviously change them, but with the click of a button, you can set up a database. You obviously have an option of leveraging the same four-step process by doing a standard create, but we wanted to give customers a choice where they can use a standard create so they can get started with RDS with the click of a button. We also provide a capability where you can query using our console editor. No database client application required. It's available for Aurora Serverless, both for MySQL and Postgres today.
So this is rolled out as of this reInvent?
This is available actually since last reInvent. This was available as a preview for Aurora MySQL last year at reInvent, the serverless version. And then later on in the year, it's also available for, earlier in this year, sorry, was available for Postgres serverless as well. You can apply DML. You can use DML, DDL, all those queries just by the management console. We talked about storage, we talked about security, and we talked about our console experience. Let's focus the value-add feature section on performance and talk about some of the features we added in our performance area this year. Have you heard about Performance Insights? Performance Insights is an RDS feature that allows customers to identify, analyze, and tune the performance for their RDS and Aurora database in AWS Cloud. So you can identify, analyze, and tune the database performance. That's the intent of Performance Insights. Available through AWS Console and AWS APIs. When I'm troubleshooting a performance problem, I'd like to get to the root cause of the issue quickly. How do I do that with Performance Insights? Now, if you notice here on the left panel, you can see there's a column called CPU utilization, or CPU as it states here. You can click on the CPU column, and if you click on that particular row, which says, in this case, 6.72%, instance dash name, you can quickly get into the performance insight dashboard, which highlights performance challenges or performance issues with that particular instance. So let's take a look. In the right panel, you will notice that there are 4 different spikes. Performance insights look at, or we call it PI. PI looks at database load based on average active sessions. In really simple terms, when I have a query that starts from application and goes to a database, it consumes a connection. Now, this connection eventually utilizes a vCPU. If there are a ton of connections being consumed, and if the connections are more than the CPU itself, or the number of CPUs on the box, then we have a construct of wait, that a particular query is waiting for a resource to be released, in this case, a connection to be available. The way we calculate average active sessions are exactly like this. The concept of looking at the number of queries and identifying what is available and what's not available. In this case, you can see that there are top 3 queries here, which all of them are deletes, and they are causing load on the database. You can filter this based on SQL. You can filter this based on host, users, or wait time. All of them are available through Performance Insights. Now, this is good if you're looking at the dashboard for a query. What about a case when you're not looking at the dashboard? Wouldn't it be cool if you can actually set an alarm when CPU load is higher than X percentage? Do something. So the answer is yes. What you can do is you can set alarms based on threshold with Performance Insights. We already publish a set of standard metrics to Amazon CloudWatch, DB load CPU, and DB load non-CPU. All these three metrics are published to Amazon CloudWatch, which means that you can use these metrics to set a threshold and then eventually apply an action, such as sending an email or send an email to a particular user when the metric goes above threshold. In this particular case, the example that we have, the metric that we are using is DB load CPU, or the database load CPU. If the metric goes above 3 for one data point within a 5-minute interval, raise an alarm. Now, let's take a look at a little more details about this. This particular host has 2 CPUs, or 2 vCPUs. If the connections are consistently more than the vCPUs on the box, this means that we are looking for some resource on the database host, and if there's a consistent concern that the connection is not being leveraged, or a query is not able to find a connection, that means that the database administrator has to either scale the database, apply an index, or do something such that this problem goes away. So the intent of an alarm like this was to give visibility to the engineering team that they can do something about it. Then we launched, earlier this year, SQL statistics. So it's all good when you can identify a query and then do something about the query. But it's hard to identify performance issues with a query if you don't know enough about the query. So earlier this year, in fact, earlier this month, we launched support for SQL statistics so that you can get cardinality of the query. In this particular case, you can get average latency of this query, update authors 3, number of rows, so rows examined, and calls per second. Helps a developer or a database administrator to look at, is this expected, or is this something that is out of the norm? And that's the intent of SQL statistics. We expect that this would allow DBEs and developers to determine if a SQL query takes too long to complete, or if a particular SQL query is called at a different rate than you expect. At a high level, performance insights, no resources to install, configure, and manage. It's consistent across all Amazon RDS and Aurora engines, and provides enterprise-grade performance monitoring tool. No additional charge for enabling performance insights for last 7 days of data. If you like, you can always add optional long-term retention. There's an additional cost for long-term retention for up to 2 years, but no cost for 7 days retention. At the same time, if you go back to the discussion we were having about Easy Create, whenever you set up a database with Easy Create, performance insight is already enabled with free retention of last 7 days data. So you don't have to think about enabling a feature or with a Easy Create. That's the intent of. That's why we picked standard configurations in this case. Now we've talked about what we launched earlier this year or earlier this month. Let's talk about some of the challenges with the modern applications and what we can do about it, or what we've done and introduce some of the concepts that we are launching at this reInvent. If I'm using an RDS database and I have an application that connects to the DB with high availability, it gives me confidence that it can mitigate database crashes, hardware failures, loss of network connectivity, or even non-availability of the entire availability zone. So it provides me the assurance that the database will fail over to another AZ if the availability zone is not has issues. But it also adds downtime. On the other hand, there is a level of hesitation that the failure could interrupt application for a brief period of time, which results in, as I said, application downtime. The challenge is that in many cases, the burden remains on the app to do the optimizations. I can cache some of the DNS entries. I could do something around mitigating errors. I could redirect requests to a read replica. But the application has to be smart enough to handle these situations. So that's the first challenge. Serverless applications require, in fact, serverless applications can use IAM database authentication. We hear a lot of serverless customers like using IAM database authentication because it provides a flexibility where they do not have to pass username and password as part of the request. The challenge is that given the nature of serverless applications, where tens of thousands of Lambda clients connect for a short duration of time, it is expensive to do an SSL connection for a short duration of time. You have a set of Lambdas spinning up. They'll try to connect using SSL, and then they spin down within a minute or matter of minutes. And when that is happening, connecting using SSL is expensive. for those apps. This processing also competes with the CPU cycles compared to what other database operations that are happening on the database. All in all, customers want this IAM authentication, but not at the expense of connection setup cost or adding load to the underlying database. And finally, connection setup rates. So database connections are finite. Again, if we take the modern applications, serverless applications, tens of thousands of database connections, tens of thousands of Lambda, so when they start up, they need connections. Now, they consume memory, compute resources on the database instance. Oftentimes, serverless applications can open and close tens of thousands of connections within seconds because they start up and shut down in response to user requests. This can exhaust the database memory and compute. This eventually affects your application. Here's an example of how it looks like. Typical picture that you see with a serverless application today. What happens when you create more connections than the host can sustain? What about modern apps that can scale out, but the database cannot? So earlier this year, we launched support for RDS Data API. We launched RDS Data API earlier in the year, an HTTPS endpoint for connecting to your database. What it did was to solve some challenges around connection pooling for specific lightweight clients. This setup provided a few key benefits. Customers can now build applications such as serverless apps, IoT-based apps, without thinking about connection pooling. And Data API used to take care of long-lived connections. Also improves app agility. It has a public endpoint, no client configuration required, again, no persistent connections required. Data API is free and is available for Aurora serverless customers, both for MySQL and Postgres. Now, that is good for HTTP access, or if you have a new app that you're building for modern apps. But how do I leverage these connection pooling requests for my current JDBC apps? There are tons of apps in the world. They're using JDBC, or they're using any other non-HTTP requests. And how do I leverage the same connection pooling capability that we just talked about for these current apps? So the issues are failover time, IAM authentication, where the connection time, without paying connection cost and DB load time, and just the number of connections or the connection establishment rate. All these challenges don't go away, but the construct of how customers solve these problems generally is through creating a proxy. What happens with proxy is that a database proxy pools connections to an application and communicates to a database through a smaller and more manageable number of connections. While a proxy server allows applications to scale more effectively, now you have to, as a customer, have to maintain that proxy. You have to patch it, you have to operate it, and unfortunately, that takes away the cycles to focus on application development. So you want proxy, but you don't want all the overhead of patching, deploying, scaling, operating it at scale. So happy to introduce Amazon RDS Proxy. Amazon RDS Proxy is a fully managed, highly available database proxy that makes applications more scalable, more resilient for database failures, and more secure. If you notice the issues we talked about around failover time, connection establishment rate, and IAMDB authentication. All of these issues are inherently solved by using Amazon RDS Proxy. Amazon RDS Proxy is available as a preview today. You can enable RDS Proxy on new or existing instances. Proxy is completely serverless, so no need to provision or manage proxy. Proxy takes care of connection pooling and helps applications scale. We believe that you can reduce the failover time by almost 66% by using RDS Proxy. Available as a preview today. So how does proxy work? The client applications connect with proxy rather than database itself, provides capability around connection pooling, seamless failovers, and improved security. Fully managed, no infrastructure to manage, and it scales automatically. Credentials can either be managed through IAMDB authentication or through AWS Secrets Manager. Again, in both cases, you do not have to pass the credentials through APIs as you create database and as you provision and manage database. You pay for what you use. Proxy itself is highly available. So let's take a quick example of what happens in today's world and what happens after you enable proxy. In this case, we have a database in availability zone 1. And because it is enabled with multi-AZ configuration, there's another standby database in availability zone 2. The app is talking to EC2/1, which is basically the primary database, and is aware about the DNS entries or the domain naming system entries for the database endpoint. Failover happens. The second availability zone 2 has now the primary database, again replicating between the primary and secondary, but now the app is talking to the database which is in availability zone 2. In the world of proxy, the application only talks to proxy. Proxy takes care of the DNS management. Proxy is embedded within the database service, so it has an additional information about the database instances, the primary instance, the secondary instance, and has all the details around how to ensure that the app gets faster and seamless failovers when they happen. In this case, it allows us to decouple the database instance and helps applications build capabilities using the proxy directly. Proxy is available in 5 regions in preview: US East, North Virginia, Asia Pacific, US West 2, US East 1, US East 2, and our Ireland region. Available for MySQL, Aurora, MySQL, and RDS MySQL, and will be available for RDS and Aurora Postgres soon. To recap, traditional JDBC long-lived connections are not appropriate for serverless apps, which is why, with the launch of Data API earlier in the year for HTTP and lightweight requests, as well as with RDS Proxy, we are now allowing customers to not worry about connections, but focus on more of application development, and we take care of connection pooling. Simplified access using Secrets Manager, CloudTrail, and all the standard integrations with AWS services. We do a lot of heavy lifting, so you don't have to, such that connection pooling, IAMDB authentication, and parameter management. There's an end-to-end encryption with SSL out of the box, and as I said, CloudTrail auditing. So in this new world with all these capabilities, there's still room for choices. over the last 10 years, RDS has added support for various engines. When we talk to customers, they expect the same fully managed experience for provisioning, for patching, automated backups, point-in-time restore in their on-premise data center as well. They like the fact that they can do that on AWS, but they want that same capability in their data center. Now, we went back to the drawing board and tried to say, how can we provide the same experience in customers' data center? So we started with RDS on VMware. RDS on VMware essentially provides the same management capabilities of provisioning, patching, backups, restores that you get on AWS in a VMware environment. So as it says, it's Amazon RDS, but in your data center. It's generally available in IAD. You can use the open source engines MySQL 5.7 and Postgres 10.9. It's also available with SQL Server 2016 SP2 Enterprise Edition. You can use the same operations, backup, restore, PITR, and support for disconnected mode. What this means is that even if the connection back to AWS is lost for a few hours, the database remains consistent, the database continues to operate, and the applications do not fail. So how does Amazon RDS on VMware works? In any application, or in an application network, in any network, there's an internet network where applications talk to the internet or have a route to outside world. There's an application network where they will install their finance app or an HR app. We've set up a cluster control network so that we can install our services in the VMware environment, and you can get the benefit of a disconnected mode in case there's no connection back to AWS. Standard operations, you can set up a database using AWS region, and after the database is set up, all the operations happen directly in the VMware environment because our control VMs handle backups, restores, and replacement of instances within the environment. You can have application VMs talking to those databases. Again, all of that work is happening within the database environment, within the customer environment or customer's data center. Now, this is good for customers who have VMware. Customers who actually have set up or bought a VMware infrastructure in their own data center. What about other customers who do not have that access? The problem still remains the same. Latency-sensitive apps, which need low latency requests back to the database. If the database is in the cloud, but the app is in their data center, and millions of transactions are happening on a minute-by-minute basis in that application, having that application talk to the database on an every second basis, where the application is on-prem and the database in the cloud, could be challenging. Databases, especially on-prem, time-consuming, complex, and expensive to manage. Why? Because you need to ensure that they are patched, both from an operating system and the database level, make sure newer versions are supported, make sure security patching is done. And finally, as developers have been building applications on cloud, now they have a challenge that they have to manage an instance in cloud and in their own data center, which means different CLI, different API interfaces, and different consoles to set up a database. So introducing Amazon RDS on Outpost. You can deploy managed databases in on-premise AWS environment, and we support MySQL and Postgres. As you may have heard about this particular functionality from Andy's keynote earlier this week, available for MySQL and Postgres, fully managed on-prem. You get the same experience of provisioning, setting up the database, be able to get backups, restores, resizing database instances, or resizing storage that you get with RDS on AWS. Same standard capabilities around availability and durability, and a unified interface, which means that developers now do not have to think about setting up CLI, setting up APIs in two different environments if they have applications in the data center as well as applications in the cloud. In fact, sorry.
That's great.
Thanks. Now, this applies across all three environments, in fact. You can set up a database in the VMware environment, you can set up the database in cloud, or you can set up the database in Outposts. All these instances will be visible with AWS RDS Console. Finally, this is how it works. It's essentially extending the current AWS environment and adding a new subnet in the availability zone called AWS Outpost. So that's the end of my presentation. I'll wrap up the presentation, and I'll be here in the room if there are more questions. Thank you.